Hello, I welcome you all to Startup Academy. This academy is exclusively for ISS and we are discussing sampling techniques in which we are on double sampling. In the previous lecture, we discussed the basics of double sampling, what is double sampling about, and estimation of double sampling. Today, we will be discussing the variance of double sampling, and after that, we'll start with ratio estimator in double sampling. So, let us begin. Now, what is variance in double sampling? You know that we took tau as the statistics. Let tau be the statistic obtained in phase 2. Tau is the statistics that was obtained in phase 2. Today we will start with variance of tau. Variance of tau can be written as estimation of tau minus estimation of tau whole square. This is the formula for variance, as we all know that. Now we can add and subtract is estimation 2 of phase 2 of tau plus estimation of phase 2 of tau minus estimation of tau. This becomes 1 and this becomes second. And this is whole square. Now opening the whole square, we will get estimation of tau minus phase 2 tau estimation of tau whole square plus estimation of E2 tau minus E tau whole square plus 0. The covariance between them will be 0, as we all know that. So now here this E can be written, E is the total estimation of first of phase 1 and then of phase 2. So I can write E as E1 E2 tau minus E2 tau whole square plus E1 E2 E2 tau minus E. This can be written as E1 E2 tau whole square. Now this unit is constant with respect to E2. We can see that this unit is constant with respect to E2. So now moving forward, we can write it as variance of tau is nothing but E1 E2 tau minus E2 tau whole square plus E1. Now since that unit was constant with respect to E2, we can remove E2 from here. So it will be E2 tau minus E1 E2 tau whole square. So here this bracket term is nothing but variance 2 of tau. This is the variance formula for the second phase, and this one E1. This whole thing will be E2 E1 tau, and outside, if we consider it, it is V1 variance of E1 tau. So we can write it as V1 E. This was E1 E1 V2 tau, and this is V1 E2 tau. So this is the formula for our variance of statistics that has been obtained in the second phase. E1 V2 tau and V1 E2 tau. Okay. So now moving on further to regression estimator. Sorry, ratio estimator. In double sampling. We know that we discussed it in the previous lecture that we will select a sample, let a large sample of size small n prime is drawn by simple random sampling without replacement from the population. Here we will consider a statistics which is x bar dash, x bar prime, which is nothing but 1 upon n prime summation I goes from 1 to n prime x I prime. This is the statistics. So our ratio estimator here is defined as we are taking capital R, sorry, y bar cap R D. R is for ratio, capital R is for ratio, and D is for double sampling. It is nothing but y bar upon small x bar into x bar prime. This is the ratio estimator of double sampling. Now we know that we cannot derive directly y bar upon x bar's value. So for that reason, we will find the values by approximation up to 2 orders. Because we are talking about sampling, double means 2, so we'll take this time up to 2 orders. In single sampling, we were taking up to 1 order. So let us consider epsilon naught is equals to x bar minus capital X bar upon capital X bar. Epsilon 1 is equals to y bar, epsilon naught is equals to y bar minus capital Y bar upon capital Y bar. Epsilon 1 is equals to x bar minus capital X bar upon capital X bar. And epsilon 2 is equals to x bar prime minus capital X bar upon x bar. We know that estimation of x bar prime is also capital X bar. How? If we are taking a sample, suppose this is the population of size capital N, and then we are taking a sample of size n dash, and then we are again taking a sample of size n. So this n dash is also a part of this population only. So estimation of the statistics from this population, from this sample, is also by simple random sampling without replacement, is the unbiased estimator of the population mean. That is why it has been taken. So here we can say that estimation of epsilon naught is equals to 1 upon y bar estimation of y bar minus capital Y bar. we know that estimation of y bar is nothing but capital Y bar. So capital Y bar minus capital Y bar upon capital Y bar is equals to 0. Similarly, estimation of epsilon 1 is also equals to 0, and estimation of epsilon 2 is also equals to 0. This we had done previously as well. Today also we are doing this. Now we will take out the other things that are required. So first thing that would be required is estimation of epsilon 1 square. Estimation of epsilon 1 square is 1 upon estimation of x bar minus capital X bar upon capital X bar whole square, which is nothing but 1 upon x bar estimation of small x bar minus capital X bar whole square. This can be written as s x square upon x bar into 1 upon small n minus 1 upon capital N. And further this can be written as, this is x bar square, 1 upon small n minus 1 upon capital N cx square. Right? Now taking the estimation of epsilon naught and epsilon 1. This will be estimation of x bar. This will be covariance between y bar, or we can say simply estimation of x bar minus capital X bar into y bar minus capital Y bar upon x bar into capital Y bar, which will be nothing but sxy upon x bar into y bar to 1 upon n minus 1 upon capital N. This sxy, we know that rho is nothing but sxy upon sx into sxy. So this can be written as 1 upon n minus 1 upon capital N rho sx sy upon x bar upon y bar, which can be further written as 1 upon n minus 1 upon capital N rho cx cy. Now estimation of epsilon naught, epsilon 1, epsilon 2. This will be estimation of x bar minus capital X bar into x bar prime minus capital X bar upon capital X bar into capital X bar. So 1 upon x bar square can be taken out, and we are left with estimation of x bar minus x bar into x bar prime into x bar. This can be written as E1, E2, x bar minus capital X bar into x bar prime minus capital X bar, given that the sample size is n prime, and this can be further solved as 1 upon capital X bar square into E1 of x bar minus capital X bar. When we remove that conditional probability, it will be this only, and it will be nothing but 1 upon n dash minus 1 upon capital N into sx square upon x bar square, which is nothing but 1 upon n dash minus 1 upon capital N cx square. This is also the probability of estimation of epsilon 2 square. We can calculate it by our own. The probabilities of epsilon 2 square and epsilon 1 and 2 are same. Now another probability is estimation of epsilon 0 and epsilon 2. This is nothing but covariance between y bar and x bar prime. This covariance term is similar to the variance term. So we can write it as covariance between estimation of y bar given n prime, y bar prime, and estimation of x bar prime given n prime, plus estimation of covariance between y bar into x bar prime. Since we have calculated the variance, which is estimation of 1 into variance of 2 of tau, and estimation variance of 2 into estimation of 1 of tau. Similarly, we have calculated for covariance. Here the covariance becomes covariance between capital Y bar and capital X bar, plus estimation of covariance between capital Y bar and capital and X prime will be covariance between Y bar and X bar prime. So this is nothing but 0 because there is no relation among Y bar and X bar, and so we are left with covariance between Y bar and X bar prime, which is nothing but 1 upon n dash minus 1 upon capital N rho Cx Cy. So now we will take the formula of ratio estimator in double sampling, which is y bar upon small x bar into x bar prime. Y bar can be written as 1 plus epsilon naught capital Y bar. X bar can be written as 1 plus epsilon 1 capital X bar, and X bar prime can be written as 1 plus epsilon 2 capital X bar. This and this will get cancelled out. So we are left with y bar into 1 plus epsilon naught 1 plus epsilon 2 into 1 plus epsilon 1 raised to the power minus 1. This can further be opened as y bar into 1 plus epsilon naught plus epsilon 2 plus epsilon naught epsilon 2 to 1 minus epsilon 1 plus epsilon 1 whole square minus epsilon 1 whole cube up till this. So I have opened the power minus 1. We will take up till second order. So we'll take up till this. So multiplying it inside, we are getting y bar into 1 plus epsilon naught plus epsilon 2 plus epsilon naught epsilon 2 minus epsilon 1 minus epsilon naught epsilon 1 minus epsilon 1 epsilon 2 minus epsilon naught epsilon 1 epsilon 2, and by adding epsilon 1 square, because after that the powers will be 2 and this is also not required because the power becomes 3 here. So we can write it as ratio estimator of double sampling is equals to y bar plus y bar into 0, 2, minus 1. Zero, 2, 0, 1, 1. This was the formula. So we can take it on the left side, minus y bar, and this will be y bar Let us take the estimation as well in this step only. Estimation of epsilon naught plus estimation of epsilon 2 minus estimation of epsilon 1 plus estimation of epsilon naught epsilon 2 minus estimation of epsilon naught epsilon 1 minus estimation of epsilon 1 epsilon 2 plus estimation of epsilon 1 whole square. Now this can be written as bias of ratio estimator, and here these can be written as, we know that estimation of epsilon naught is 0, this is also 0, and this is also 0. Estimation of epsilon naught and epsilon 2, this is the formula 1 upon n dash minus 1 upon capital N. One upon n dash minus 1 upon capital N rho Cx Cy. Now the next formula is E naught, epsilon naught and epsilon 1, which is 1 upon n, 1 upon n minus 1 upon capital N rho Cx Cy. Epsilon 1 and 2 will be 1 upon n dash minus 1 upon capital N Cx square, and epsilon 1 square would be 1 upon n minus 1 upon capital N into Cx square. We can recheck it. Epsilon 1 square is 1 upon n into 1 upon capital N Cx square, and epsilon 1 and 2 would be 1 upon n dash minus 1 upon n Cx square. We have written the same. So now taking the common terms, we can write this as y bar 1 upon n dash minus 1 upon small n, or we can write 1 upon n minus 1 upon n dash Cx square minus 1 upon n minus 1 upon n dash rho Cx Cy. Bias of ratio estimator of double sampling can be written as y bar into 1 upon n minus 1 upon n dash into Cx bracket Cx minus rho Cy. Now here, if our n is very large, then bias becomes negligible. If n is large, then this will be n will be infinite, and 1 upon infinity is 0, so the bias becomes negligible. And if Cx square is equals to Cy, then the regression line passes through origin. These are the two results that we have to write in the final answer of bias when we calculate the bias of ratio estimator. So this was it for today. I hope you got what we have done in the class today. I would request you all to keep on watching the lecture with consistency, because it is the key to your success. And if you are serious about ISS 2026, then you should be consistent in your hard work. Otherwise, nobody is going to save you. All the best, and thank you.